Hi everyone, my name is Jakub, and I've been a cloud slash DevOps slash platform slash whatever buzzword engineer for the past 8-ish years. And right now, today, I would like to tell you something about architecting a future-ready cloud-native platform. First, bloody hell. Well, I guess I'm not going to tell you that much yet because the slides aren't switching. So give me a moment, please. Ha, gotcha. Okay, so first things first, allow me to introduce the company I'm working for right now. Right now, I'm working with Labyrinth Labs, and we are a pretty small company. There's just about 20 of us, but I think we are making quite big waves in the industry. We are an advanced AWS cloud partner, and we manage more than 100 Kubernetes clusters across various customers. What we mainly do is help customers with DevOps, cloud, Kubernetes to set it up, to maintain it easily, and to be able to deploy their applications there. And we do it in such a way that we are trying to make them not just the technologies, but also the businesses cloud native and future ready. Cloud native and future ready. I've seen that somewhere. I've seen it on the first slide. So what the heck is this going to be? Is this going to be just a sales talk? I'm going to be talking about the company and trying to sell you our platform as snake oil? Well, maybe, not really. Platform, cloud native, and future ready are really buzzwords. They are used in sales. That slide is the normal slide that we use to introduce our company. Platform is the newest of these buzzwords, most likely. Like, I don't know, 2 years ago, everyone had to have a platform. Every DevOps engineer suddenly changed their handle to platform engineer. Every company started to promote platforms, even though they didn't have platforms. And, well, everybody tried to really have a platform. Even an older buzzword is the cloud native. Ever since cloud came up, cloud providers tried to get you to use their services, well, to get your money. So they invented cloud native. And future ready, come on. If you have an application and you call it future ready, it just sounds cool. But is it really that way? Maybe these words aren't just buzzwords that we use in sales, marketing, and whatever. Maybe there's some substance, some meaning behind them. So in this presentation, I would like to delve a bit deeper into that and show that they might actually mean something. And to begin with that, we should probably define cloud-native applications. Cloud-native applications aren't just simply applications that live in the cloud. Cloud-native applications are applications that fully use the capabilities of the cloud. So what could these capabilities be? In the cloud, public, private, you have an illusion of infinite resources if it's, well, at least configured correctly. If you have the money, you should be able to get it, whether it's servers, it's storage, it's DNS, or whatever. So cloud-native apps fully utilize this. So let's say when you need a bigger server for the app, you get it. When you need less, you get rid of it, and you pay only for what you need. A similar example to this, or a similar advantage that comes out of it is scalability. So cloud inherently allows you to scale your applications. If you need more resources, you get them. If you need less resources, you can get rid of them, whether it's storage, compute, again, anything like that. Clouds also enable your applications to be highly available. When you have a data center somewhere, I don't know, in your back room, if somebody cut the connection, you were done for, at least until somebody came to restore it. Cloud providers usually try to place their data centers, because it's just their computers. They try to place their data centers in different locations so that you can place your applications there, and one of those data centers, those zones fail, your application doesn't. Last thing is cost optimization. So if you use only the resources you need when you need them, you inherently save money. If you have to buy servers for 5 minutes of fun, like for example Black Friday, and then sell them again, it's not ideal, but that's what you can do in the cloud. Nothing, 5-minute blip, nothing, sell it, and only pay for the 5 minutes. Cloud-native applications also had to be modified to work with the cloud. In the past, we had mostly monoliths. They were broken down into small microservices and smaller applications which live independently, are managed independently. And from, I don't know, architectural point of view, or I don't know what point of view, whatever, containerization and serverless was used to enable this. So when we think about containerization, we think about packaging everything together, deploying it anywhere very simply. Serverless, there's another buzzword, serverless allows you to run without thinking about servers. So when we have these cloud-native applications which are now different and work in the cloud, you need some sort of tooling to manage these applications, to develop them and maintain them easily. So there are several categories you can put it in, so of tools that we have for that. The first category is provisioning. So if you want to run in the cloud, you need to provision the infrastructure. You need to provision the servers. You need to provision some registries where you put your application images, for example, or also some security and compliance measures, for example, ciphering keys, and so on. So these kinds of tools help you do that easily so that, for example, you don't have to use UI to get the 1,000 servers up and then maintain each one independently. Second category is runtime. So we have like the solid foundation. Now we need a standard way of how we can deploy the application to the cloud, or how to deploy the containers in the cloud, how they can run in the cloud. So for that, they need some kind of container runtime, so that when they are placed on the servers, they run in some kind of standard ways, either to start in standard ways, the security is standard, and so on. Containers also inherently need storage and network. From storage point of view, I mean disks. From network point of view, I mean mostly IP addresses. So they need some kind of identifier in the network that will allow them to communicate. Third category is orchestration. When it comes to orchestration, if you have one monolith, you place it on one server, you deploy it on one server, you don't have to think about anything more. But when you have thousands of microservices, you need to deploy each one independently, and you need to make them communicate and facilitate the communication. So that's what orchestration is about. It allows you to deploy many applications into the cloud, allow them to discover each other, allow them to communicate with each other. When we have these things, right, we also want to say, hey, I actually want this application there, and want there in a standard way. So for example, I can write a simple, no, not really a script, simple YAML that tells me, hey, I want this application here with these kind of parameters. Also, the applications need some kind of dependent or peripheral resources, for example, databases or messaging and streaming. So communication doesn't always go request-response, but sometimes you need to stream, sometimes you need to send messages which are then consumed by workers. Also, you need to store data somewhere in the cloud. Last but not least is CI/CD. So you want to deploy those applications there in a standard way, easily, without having to touch basically anything, just one button, and it's there. And the last category is observability. Observability, when you are running in the cloud, when you are running multiple services, you need to know what's actually happening there with your application and with and also with the infrastructure itself. So when it comes to observability, we have tools that provide metrics, so some kind of numeric values. We have logs, which provide some sort of context and show you a story of what's actually happening. Traces, where you can trace how a request went through those many microservices. And profiles, which tell you, for example, which line of code is very suboptimal and you use a lot of memory, a lot of CPU, or a lot of time, allows you to optimize. In the field of observability, we also have chaos engineering. So you want to introduce some faults and to test if the system is actually resilient enough. So, and get some actionable data about if it's secure, if it's reliable, highly available, and if it can survive any outages. Well, if you guys are familiar with the CNCF landscape, you know that these definitions are just stole straight from there, slightly modified. CNCF Landscape is an awesome website which collects all these tools in these various categories and allows you to see allows you to choose which tools, or rather gives you a collection of tools you can choose from when you are solving certain problems. There's one slight problem though. CNCF Landscape isn't the entire cloud native landscape. CNCF only knows about so much and doesn't put everything there, of course. There can be newer services. There can be services which are proprietary to the cloud providers that don't get there, but are still viable for you. So when you are constructing your platform or your cloud native stack, how do you actually choose these services? Which services do you choose? Do you go for cloud native stack, or do you go for, I don't know, just random first Google link that you get? Well, that's a good question, which I ask myself. So, you have, in order to determine if a tool is viable, you need to define some criteria. The first thing is, I call it business needs, but it's kind of dumb. What I meant by that is, when you are building a platform, when you are building a cloud-native stack, you are essentially solving a problem. So you need to choose the right tools for the right problem. When you are solving observability, you will most likely not be deploying CI/CD pipelines out of the box. First, you need to solve observability. When it comes to these, choosing the right tools, time and cost of both choosing these tools and then maintaining them is a huge factor. So it might actually be better to spend more time on choosing and deciding which of these services is better, rather than deploying it quickly and then you realize that you can't maintain it at all. Or that it's too costly to maintain because, okay, you thought it was cute, but suddenly traffic spike, it scales terribly, and you have a problem on your hands, and you need to replace the tool. Another criteria is your preference. Like, CNCF Landscape is bloody huge. Like, look at this. And a lot of these tools do the same thing very similarly, very well. So sometimes it just comes down to what you like. How do you like to work with it? Do you prefer Go? Do you prefer Java applications or whatever? Do you prefer this UI? Do you prefer CLI? Up to you. Some tools are just too new. They have interesting prospects, they have interesting concepts, but since they are just new, you can't really use them in production, so you also need to think about that. And I think concern is security. When you are choosing third-party tools, or maybe coding your own, maybe you are in an industry which requires you to be compliant to certain certifications, or where you need to be very sensitive about how secure your tools are. And last but not least, with our one of our buzzwords, which is future readiness. As we all know, the future is always coming. Right now, well, in the moment, and so on. And what we know about the future is that it's bloody uncertain. We don't know what's actually going to happen. A good example in IT technologies, for example, is the rise of ChatGPT 2 years ago. We knew AI was coming sometime, like the research groups, there were some tools and so on. It's already being used. Suddenly ChatGPT, boom, changes the entire business landscape. It changes how people think, how people use it, how people develop applications. So we don't know what's going to happen. If we don't know what's going to happen, how do we make a product that's future ready? How do we make a platform that's future ready? Well, we can guess. Okay? Maybe you'll guess right, maybe you'll guess wrong. You commit to something, it goes right, it doesn't, you'll see. But is there some kind of more systematic approach? Or is there something you can build on top of? And what you can actually build on top of is the fact that there's one certainty that at least happens in our industry, in IT, is change. As time goes on, stuff changes, technologies, business needs, user needs, and so on. And since we know that things can change, the main thing about future readiness isn't guessing, like, ooh, we are ready for everything, but it's more about being prepared for the change and trying to figure out what kind of things can change and either be flexible enough or prevent it. So, again, there are some kind of well, not criteria, but categories of changes that can happen. First of all, user and business changes. So everybody has needs and wants. For example, when you're building a platform, you're building CI/CD, you are building metrics. I don't know, suddenly you realize, we have a shitty logging system we need for our compliance audit next month, so you need to build something else. This changes. You need to be flexible enough to, or you need to choose tools that are flexible enough so you can switch from one to the other. When you have users who develop applications, suddenly somebody else might come in like, hey, we are not going to be doing this, we are going to be doing this, we are going to be deploying or developing something else. So we need to change the tooling to match the new requirements. That's the word. Second thing that changes are the tools that you should use yourself. They evolve as well. There's a new release, I don't know, for some tools every month, for some tools every day, for some tools every year. And new features are added, new fixes are added, new things are removed. A lot of things are removed, and you need to count with that. So when you are building a platform and choosing those tools, you need to know how they change, how they behave, or at least try to gauge it. You need to also keep a lookout for alternatives. For example, some time ago, I might have chosen a tool that does this, but I don't prefer, it's completely not my preference. It's terrible. So right now, a new one that I like came up. I can replace it and choose the new one. What an interesting, changes that happened in the past few months, I would say, are changes of licenses for certain applications. For example, Terraform, which has been widely used for infrastructure management, Jakub suddenly decided, oops, we're going to change the license so we can be sold. This created a ripple in the community, caused some concern. So you need to also look behind, who's behind those tools, who's maintaining them, who's making them happen, so that if, for example, license change of an open source project that you've chosen happen, you are ready for that. Another thing, come on, we as maintainers or creators of the platform change ourselves. So sometimes it's just about choosing the problem you like to have. Not so long ago, we had the same dilemma, do it this way or do it this way. So in the end, I've decided which problem I wanted to have. That was a certain tool. We're going to have to make it scalable or a bit more scalable. It's going to be a hassle, but it's going to be an interesting hassle. There was another simpler solution that had other drawbacks, but I've chosen that one just because, that's what I like to have. Also, your experience changes. As your experience change, your tools change, and so on. So when we have all of this in mind, how do you actually choose those tools? Well, important thing to do is to do your research, like all the time. Google a lot, ask ChatGPT a lot, experiment a lot. If you don't experiment, just rely on documentation, things may be hidden for you. You need to actually deploy that stuff and see what's happening with it, and then you will see if it's good for you or if there are some, I don't know, hidden obstacles that prevent you from actually using the current tool in production. So we have our tools, they're future ready. We've tried a lot because it's been difficult. Do we already have a platform? No. There is some magic powder still missing from actually having a platform, because when you have those tools, in your company, just one developer may have them, or just one engineer. And only he uses them. So the important thing that's also been stressed in other talks at this conference is to treat your platform as a product. But what does it actually mean? First thing you have to realize is that your platform has users. And it has people who use it and who maintain it, and people who interact with it. And they have to interact with it in such a way that's simple for them and quite understandable. So the thing is, you need to also construct some kind of interface. It doesn't have to be UI. It doesn't have to be like Backstage. The interface might be, I don't know, well-defined documentation. That's the lowest level of them. Or it can be a simple configuration file for what you need, so that the developers can, or the developers or engineers who work with your platform can actually use it effectively. Second thing is standardization. If one guy has all the tools, he maintains them his way. It's not entirely ideal. Sometimes you need to standardize them. So you need to both create them in a standardized way and maintain them in a standardized way, so that your overhead, what you have to think about, what you have to do, is as low as possible. And when it comes to introducing platforms to companies, also the processes and the mindsets of people who both use them and maintain them have to, well, don't have to change, but may have to change. So we need to adapt that you have actually a platform that you can work with and work around that. Last but not least, you need to use the observability of the platform. When your platform has observability tools for the applications, you can use the same observability tools to observe also the platform itself, because they come on in software. So what are you looking out for? First thing is to check if it's actually adhering to the goals you set. So does it do what I set out to do? Is it fast enough? Is it slow enough? Well, slow enough is not the thing you would be looking for, but is it fast enough? Is it efficient enough? Is it cost effective enough? And so on. Also, you need to gather feedback from the users and from the maintainers to see if the platform is actually up to par, if there are some changes that they would like to make, or if everything's absolutely okay and we can just keep it as it is. We at Labyrinth Labs, now come to sales talk. We at Labyrinth Labs have created our own cloud-native and future-ready platform, which we call Lara. What this platform allows us to do is to spin up environments at our customers quickly and to get them to the cloud and deploy their applications quickly and efficiently. And we layer this platform, or rather this platform is divided into certain parts. So the first part is, which we put out as usually the infrastructural part, so Kubernetes cluster, AWS account, and so on. But we also have other portions, observability, security, I don't know, maybe CI/CD, which different customers, different users can either decide to have or not to have. Most of the time, the users choose most of them, but it really depends. What kind of tools do we actually use? So what have we chosen? From the provisioning point of view, we are provisioning our infrastructure with Terraform. I know I've bashed Terraform with hash corp changes and so on. That's open tofu in the future, maybe. But right now we are using Terraform, which is quite easy for everyone to maintain. We can see what's actually happening, and we can see what's going on. Lara is focused on AWS, by the way, so it doesn't work with other cloud providers at the moment. From the runtime point of view, most of our servers run containerd. That's mostly a standard for us these days. But I don't know if I have anything other to say. Regarding storage options and networking options, so getting IPs and so on, we use proprietary technology from AWS because they have some really nice things there, which give you IPs, which give you storage, and so on. Third thing, what was the third thing? So for orchestration, Lara helps you spin up Kubernetes clusters, so Kubernetes is an awesome orchestration tool. And also, for example, Argo CD, which is actually a CD tool, so no, that's bullshit. So from this, I would mainly say Kubernetes as an orchestration tool. Sometimes we also use service meshes such as Linkerd. Then we have application definitions, so mostly we don't deploy the applications ourselves. Customers come in and plug them themselves, but what we are mainly compatible with is Helm, which is basically a standard these days. And we allow Argo CD to deploy your Helm charts to your environments. Last but not least, we have observability. And in our observability stack, we've decided to go with Prometheus and Thanos for metrics, Loki for storing logs, and Vector Agent for getting those logs into Loki. And for visualization and notifications, we use mostly Grafana. When it comes to our platform, or basically any other platform, there are some advantages to having it over just having DevOps process and DevOps teams. What we've noticed with Lara, especially, is that it allows us to get the product of the customer to production much, much sooner. So we build the infrastructure quickly, they can integrate it quickly, get to production, and just, well, start selling and start making money. This also happens when you have an internal platform. When you have an internal platform, and you are in a larger company, a new team creates a new application, they can just deploy it via that platform, and they don't have to think about the tooling. They can just focus on the application itself. Lara also, as other platforms, I would say, also helps us reduce the management complexity of your infrastructure and your environments. So when you have Terraform, that's the interface we have chosen. We don't have fancy UI or anything. Our fancy UI is Terraform. So when somebody comes there, they can configure anything from Kubernetes clusters to the add-ons that are running on those clusters to observability tools via Terraform, which then provisions Kubernetes resources and maintains them. And as we've seen, as our customers grow, Lara and other platforms should also scale with the customer demand. So you get more users, you need more underlying servers. The tools that you choose should be scalable and should give you those, for example, more servers or more resources. So, in conclusion, I hope I've demonstrated that future-ready cloud-native platform aren't just buzzwords. It can actually mean something. You can think about them, and you can choose your tools, actually create platforms which are cloud-native, future-ready, and really just awesome. So when you need to think about how you choose those tools. You need to think about users. You need to think about what people are doing. You need to think about what things can change, and be prepared for those changes. And in the end, having a platform, as been demonstrated, I guess, on other talks as well, is really helpful for teams and for companies. So with that, thank you for your attention. And ready for any questions?
We don't have any questions in the Slido, but is there any question? I can hand you the mic if you want. Like last minute question. No?
I've been that clear.
Okay, thank you so much, Jakub.
Thank you.